Thank you. So here's my outline for the day. First, I'm going to go over some terminology, quality assurance terms as they relate to testing. I'm going to go over the goals of automated regression testing, and then a combined example demo showing how you'd apply these ideas to an actual website. After that, I'll go over some limitations to this style of testing, and finally, some recommendations on how you might apply this to your own projects. First, a little bit about me. I focus on, I'm a software engineer, and I focus on quality assurance, automation, and tooling. And currently, I work as a quality assurance engineer at Zapier. A little bit more about that later. For the past several months, I've been building a suite of automated end-to-end regression tests. So before we get into the goals of regression testing, I'd like to define some terms as they relate to quality assurance. First term is unit test. I hope most people are familiar with this idea, but I'll describe what it means to me. A unit test is a developer tool. It's written by the developer as the code is written, possibly before, if you're doing something like TDD. And a failure of a unit test should point back to a specific part of the code that has the problem. So the purpose of unit testing is to enable refactoring of the code that you're writing. A level up from this is the integration test. Some integration tests are really just unit tests that know too much. But ideally, an integration is one of two things. It's either testing multiple units of code together, or they're tests that involve something that's outside of your control. Something like a persistent storage, or networking, or file I/O, something that's not your code, but something that you depend on. The integration test is still primarily a tool for the developer, but you probably shouldn't be relying on it just for immediate feedback on the code you're writing. The purpose of the integration test is to confirm expectations of your whole module. And then above that is the system test. Depending on the industry you're in, you might hear terms like module, subsystem, subintegration. But for this talk, system just means the outermost test that can be performed on your product. And I'll use the term end-to-end interchangeably to denote that no part of the product is out of scope for this kind of test. These tend to be written out of band or after the fact. And because of this, the main purpose of these is to detect regressions in your system. In terms of volume, you want to start with a nice base of unit tests. Not all teams distinguish unit tests from integration tests. But the main advantage of splitting them up is just for performance reasons. It's usually faster just to run your unit tests. And then finally, you should have some tests that cover the whole system. And while having a lot of unit tests is valuable, having just one single system test might be a better use of your time than focusing on integration tests. So with automated tests in place, which is the bottom of that pyramid there, we can now cover some more common scenarios and run some tests that are more fruitful, such as scripted and exploratory. So for scripted testing, you're following some sort of procedure, and then exploratory testing, you're kind of going off of a charter to explore areas of your app that you might not have touched before. So with that background on terminology, I'm now going to go over the specific goals of automated regression testing. So the rest of this talk really only applies to web-based applications, but hopefully you can map these examples onto the products you work on. If not, catch up with me later. Let's chat. So I'm first going to define the three different types of environments that we can run tests on a web app. On the right, we have production. This is the instance of the app that your end users interact with. And anomalies detected here should be recorded as bugs. We want to avoid introducing regressions into production. In the middle is staging, which is pre-production. This is where we test how new features interact with each other. And then finally, on the left, we have review servers, one for each new feature, ideally. Some places might call these QA servers or review apps, and at Zapier, we call them review labs. So the first goal of automated regression testing is to assist with the approval of new features. Regression tests can act as a sanity check on new features before manual testing. And because each review lab is running a full instance of your product, opening it up lets you test the entire stack, things like JavaScript, front-end form validation, sessions, tokens, cookies. So after manual testing, we can approve the feature for integration. Staging is the first place where new features get to interact. And as pre-production, staging should mimic production as much as possible. There might still be shortcuts like smaller databases or shared infrastructure, but you can test the main functionality. This is where you could cover things like Django asset collection, URL routing, actual browser redirects. And automated testing here can help uncover unintended feature integration. Once multiple features are working as expected, they can be promoted to production. So at this point, our new features are live, and we can run regression tests against them to check for anomalies that might have happened during that release process. Things like failed migrations, because production data is slightly different, issues with caching, or anything else that's just different about the production infrastructure. Finally, some or all the automated tests could be run at will. They could verify that an issue we experienced has been resolved. Maybe we just changed some data or some configuration files outside of the scope of our normal delivery process, and we want to verify that. We can also check to see that our third-party dependencies are still functioning correctly. So the next section, I'm going to go over a layered approach to writing end-to-end tests in Python. So each step here is just going to kind of build on the last. For this example, we're going to be testing part of Zapier.com. Zapier is a workflow automation tool that connects the work apps you use every day. Integrating with over 1,000 apps, Zapier builds processes that automate time-consuming tasks and boost productivity. One of the largest features we rolled out last year was team accounts. These let groups share their workflows in an organized manner, share third-party authentication, and have a shared billing account. Part of this rollout involved this new Teams wizard to set up your account. It involves picking a team name, adding a shared credit card or PayPal account, and then inviting people to your team. For these examples, we're going to focus on the credit card form, but specifically that input and this button. To power our regression tests, we're going to use Selenium. Selenium is a tool that knows how to communicate with web browsers and interact with elements on the page. There's tons of language bindings and frameworks. We're going to use the Python bindings, of course. At its core, Selenium is all about finding and interacting with DOM elements. So for this test, we need to locate the credit card number input. Now, you could find it with XPath, which is that first example. That's OK. A lot of capture playback tools use this. It is immune to superficial style changes on your website, but it breaks if any layout changes. And it requires a lot of comments in your code because nobody's going to know what that is looking at it. Better would be to rely on CSS. So if you have well-named CSS, that might be enough information to figure out that we're talking about the credit card input number. The best, though, is if your fields are just named. If your input's just named that, then it's also going to be good for screen readers. They're going to find it the same way. We also have to find a button. Same way, we could use XPath, but we're not going to. We could use CSS. That one's not as great. That doesn't really tell me that that has anything to do with starting a trial. Or we can just find it by the text of the button, start trial. So here's what it looks like in code using native Selenium bindings. So we import WebDriver. We're going to use Firefox for this test, create an instance of that, and tell it to get a URL. I'm going to verify that we're on the right page just by looking for a string in the HTML. Then we're going to find that credit card input and send it some keys. And then we're going to find that button and click it, and then verify that we're now on the team invitation page. So this is a fine way to get started. These are all raw Selenium APIs mapped into Python, but it's rather verbose. So, but I prefer to use a library called Splinter, which is sort of an abstraction layer around Selenium. Now the WebDriver instance is composed into this browser object, and a lot of the common actions are pulled into single methods. So now we just say browser, and you can say any name of a browser. You don't have to hard code the actual class there. And now we're saying visit a URL. Sounds a little nicer. And then we're checking HTML in the browser. And now we just have a fill method, fill the credit card with that number, and then find by text and click it. So I think this looks a little nicer. And we could write out sequential steps like this, and that could be our whole test. But you'll notice that it's not very extensible. Credit card numbers hard-coded, for example. We need to do something about that. So the next logical step is to apply what's known as page object model. In this approach, you create a class for each view of your application, so that you have reusable objects throughout your tests. So we have a team setup billing class, the URL that view lives at. When we initialize it, that's when we create a browser and visit that URL. Add a nice dunder contains method, so we can just say, like, if this string in the page. And then add some additional helpers to fill the credit card number for us and click the Start Trial button. So now our test is simplified. We just create an instance of this team setup billing, verify we actually got there, and then fill the credit card, click the trial button, and verify that invite our teammates is on the page. To me, this seems like the ideal level of abstraction. I've also found that it's useful to build helper functions for common tasks so you can reuse code between tests. So a lot of tests need a user that's part of a team. So here's a helper function to just create the team. You can pass in some parameters, or it'll just generate some defaults. So we can get a team, get a test credit card to use, go to the team setup page, and just complete the wizard right away. And so the example, like this team, or this test only cares about inviting team members. It doesn't really care about the setup. So we can just call our create team helper, get a team ready, and then go through and test the invitation feature. So let's watch that actually work. So this is a fully automated test using PyTest. It's opening up our staging server, and then using the Faker library, it's going to generate a new user and have them sign up. And then complete this onboarding process by picking a couple random apps. We're going to go with Slack and Trello. Good choices. You notice on the right side, it's kind of logging a little bit of extra information. And behind this, it's actually taking screenshots of every page and tacking that text onto the header of the screenshot so you can watch it later. So now we're going to go to that team setup wizard. And we're going to, once this loads, click through. We're going to use Faker again to generate a random team name. They all tend to be law firms for some reason. And then we're going to pick credit card for this test. And then it's going to generate with Faker a test credit card that'll work on like Stripe test credentials. But that's actually like processing the payment. It's just not actually going to cost anybody money. And then finish the setup wizard. And then you'll see on the right, it'll say passed in a second here. So that test passed. So that we run just all the time, before we deploy or after we deploy on every new feature. But what if we want to explore something a little more advanced? That was just a standard like happy path through credit card submission. In this example, I've launched a Jupyter notebook, and it's reusing the same page object model for team setup. And then you can execute each cell. You could either run them all in order, or you could go back and forth, run them in any time. So what this is going to do, it's going to go back to that. It's going to finish onboarding same way, well, actually, I'm going to finish the onboarding manually. The nice thing with this is you can interact with the browser manually while the tests are running and go back and forth, and the session's just shared. So now it's going to go to that team setup wizard. And I'm going to run through it right up to the point where it's about to fill in the team name. And instead of using the generated team name, it's just a Jupyter notebook, so you can create more cells, modify data, and the state is maintained across. I think that's almost loaded. So I'm going to create another cell here and actually modify that instance of the team to change its name. You could also do this to change credit card, change any sort of any of the models involved in the testing. So now when it runs that automated step, it's now going to fill in a different team name. Then I'm going to let it run through and pre-fill the credit card. But then I want to go back and manually try a few different scenarios. What if we try an invalid credit card or an empty credit card? So that's our valid test credit card, but we can go over there, try submitting the form again. So we get the error we expect. We see that our dialogue's being updated as we type. And as soon as we have a valid credit card, it's updated. So I use this to just explore all sorts of different scenarios, but it saves me a lot of time not having to create new accounts and type all the fields in. So that's a sample of what we've been able to build at Zapier. But it's not a silver bullet. There's a lot of limitations to this style of regression testing. First one is dependencies. So your site's dependencies affect test results. Internal data, so synchronizing things like billing plans, email templates, maybe your help or blog content. If those are related to tests, you might get a false failure. Also, external services you depend on. Maybe one of those services you depend on, like Stripe, is broken or behaving differently, and that might affect your test results. Now, this is something you want to know about in production, but it also adds to just the cost of maintaining the tests, knowing that there's so many moving pieces that could cause an automated test to fail. You know, the automation might not pick it up correctly. So browsers, obviously compatibility testing is important, but when you're just trying to verify some existing functionality and your browser updates and that breaks a test, it just adds some noise to your results. Authentication has been difficult for us in automated testing. OAuth is hard. Essentially, we can't test OAuth on our review servers because the URLs are constantly changing, and your OAuth endpoints need to know where they're expecting a connection to. Two-factor auth is hard to automate. I mean, it's supposed to be hard to automate. And then testing any sort of administrative or dangerous features through automation, like deleting users. Want to get that right and don't want to delete all your production users. And automated tests can't really help you validate your user's experience. Only a human can verify that the software truly matches the designs. One thing that works great is let your automated tests cover basic functionality and then get your designers involved in testing to go that last mile. Any sort of visual things, the automation doesn't care about animations or responsiveness, like the way buttons shift around. We do take some screenshots and we can have designers look at that, but you really want to get humans involved, either internally as alpha testers or externally as beta testers. It's also been really tricky for us. We do a lot of A/B testing, and having the automation handle all the different permutations of the site is tricky. And then finally, automation requires maintenance. And this is true of all sorts of automated testing. You have to keep your tests updated as the code changes, as functionality changes. For this style, it requires a lot of monitoring of the tests, making sure failures are legit and not just caused by some like flaky data or something changing out from under you. And coverage is a little trickier at the system level because you're not really tracking to the code. You're kind of thinking coverage of your entire product. But if you're still up for the challenge and you see the value in this style of testing, I'm going to go over some lessons that we've learned to help make this easier. First thing is just simply improving the testability of your site. If you, as I mentioned earlier, if you name your inputs, it's a lot easier to fill them in. In general, accessible sites are testable sites. If you have well-named CSS, well-scoped CSS, designers like this too, and it also makes testing easier. If none of that's feasible, consider adding IDs onto critical elements and just keeping those up to date to make locating them in the DOM a little bit easier. You can cheat a little bit. So we have some, like on staging for certain test servers, we've disabled some of our CAPTCHAs so that we can create lots of accounts for testing. Otherwise, you know, the automation gets kicked out of the system the same way a spammer would. You can use test credit cards. We have our staging server configured that we can sign up and pay with Stripe test credit cards. You could also consider exposing some of the internals, maybe like states of caching or like states of various things that don't actually show up on the site but are important to check. And then adding some functionality to your site to make cleanup easier. For example, like for our test users, we use like a custom email domain we own so we can identify that it's a test user and not a real user. And then we can filter these users out of metrics. So internally, we just unload our analytics JavaScript, and then externally, we can create filters so they don't show up in our reports. And then because we can find them easily, we just have a scheduled Django admin command to just delete these users periodically. So finally, here's what a roadmap could look like for your team. First, start with just a single test. Whatever is the first thing somebody does on your site. If it's an external site, maybe it's sign up. If it's some sort of internal portal, maybe it's login. And then start running that test every time you deploy. And if it fails, maybe you'll think about running it before you deploy. After that, start looking at areas of your product that have low coverage but would have high impact. So things like sign up, payment, contacting support. If any of these went down, for us, that would be terrible. So those are where we started with regression tests. And then look at just other business critical, whatever is tied to your KPI or true north metrics. Start testing those next. And then lastly, let your own process drive what you test next. Look for trends in your outages that you document in your postmortems, hold retrospectives, discuss which area of your product you think are getting flaky or start failing more, and consider adding tests in those areas. So thank you and good luck.